All right, welcome back, boys and girls. This is the drive-thru sponsored to you by the deli. Hungry? Stop by the deli. Make yourself a Reuben on light rye with turkey pastrami and extra sauerkraut and Thousand Island. Okay, this is 10-2, number 109. The problem reads, find the tension in each of the supporting cables in the figure below if the weight of the crate is 500 newtons. Okay, at this point, if you don't have the figure, you should pause the video and take a look at it. What I've done is I've translated A, B, C, D into coordinate points on our three-dimensional system. Now we need to get vectors. So vector AB, okay, we could write, remember B is the terminal point, so that's going to be 0, 70, 115. Remember, 0 minus a negative 115 is positive 115. Vector AC is going to be negative 60, 0, 115, and vector AD is going to be 45, negative 65, and 115. Okay, so we know that this box is balanced. Okay, we also know that it is not swaying, and that's kind of the physics key to this question. Okay, there is no tension in the x direction. There is no tension in the y direction. All of this tension is being pulled from the vertical due to the gravity exerted on the box. So what we can do with that is we can set up a system of equations. We know that the sum of the forces in the x direction will be 0. Okay? So what we're going to do is say there is some constant that we can multiply each of these vectors by such that when we add it up, the vertical tension will equal 500. So here's our system of equations. C1 times 0 plus C2 times negative 60 plus C3 times 45 is going to equal 0. When we add up all of our x tensions, we will get nothing. There is no x tension. Okay? C1 times 70 plus C2 times 0 plus C3 times negative 65, that also equals 0. And finally, our third equation will be C1 times 115. Okay, I'll just write it out. Plus C2 times 115 plus C3 times 115. That equals 500. Now, at this point, I am not going to solve this system of equations by hand. I would hope that you wouldn't either. You've taken a lot of math classes in your life, including Algebra 2, and in Algebra 2 you learned matrices, and in matrices we learned how to use a TI-84 to solve a system of equations for us. And if you don't remember that, that's part of the reason double accelerated isn't the best idea, because you learned that when you were a freshman and now you're not capable of using it. So this would be a good chance for you to go back and solve those equations in your TI-84 or your TI-Nspire. What we end up getting is, let me check mine real quick. Okay. C1 is 104 over 69 C2 is 28 over 23 and C3 is negative 112 over 69. Now you might be worried, how can that be negative? Remember, these C's are going to multiply by our vectors to get our final resultant vectors. Okay? So all that means is it's going to affect the direction of vector AD, the direction of the tension running through vector AD. Because when we're talking about the amount of tension, we have to take the magnitude of AD. So when we fill in C1, C2, and C3, and then find the magnitude of those resultant vectors, you will end up with this. The first force has 202.9 newtons. The second force has 157.9 newtons. And the third force has 226.5 newtons. So that 500 pounds of tension, sorry, that 500 newtons of tension, I probably said that wrong throughout the video, that 500 newtons of tension is dispersed into the 3 wires in those 3 forces.